This is a defined role within the project team. The hazard log manager is the person responsible for ensuring the log is kept up to date with the latest available information and that actions are being completed by designated persons. The manager may be only one of a number of specialist safety engineers who work on a project. This team will perform safety assessments using techniques such as failure modes effects analysis, fault tree analysis, and hazard and operability studies. Working together, outputs from the analyses will often be arranged or processed to minimize the work of inputting it into the log. However, the hazard log manager must still ensure consistency between different information sets and that everyone is working to the same defined hazard list. The safety team is often an active part of the systems engineering team, with close ties to a number of system specialists. This may include dedicated systems engineers, usually headed by a lead system engineer who takes overall responsibility for activities in the area. This person manages a multidisciplinary team and maintains a clear focus on designing and integrating complex systems. A systems engineer needs to think above the other disciplines, considering issues across subsystem boundaries. Requirements engineers are responsible for defining, capturing, documenting, and maintaining requirements, including safety requirements that are generated to mitigate against hazards. On all of these safety-related requirements, the hazard log manager will liaise closely with those documenting the requirements. Reliability, availability, and maintainability engineers work hand in hand with their safety counterparts. Safety engineers and RAM engineers share common skill sets, use the same tools and techniques, and often operate competently in either role. Depending on the project size and organizational makeup, there may be only a single team of RAMS engineers rather than separating the two functions. Note that International Standard EN 50126 is for the specification and demonstration of reliability, availability, maintainability, and safety, all taken together. Other typical roles embedded within the system engineering team are human factors specialists and EMC experts. Human factors is clearly engaged with safety activities, trying to minimize human error within systems. Electromagnetic effects can cause unintended coupling of systems with potentially serious consequences. Discipline engineers comprise of dedicated design specialists in areas, depending on project scope, such as electrical power, signaling, track, civil engineering, etc. Required expertise often also comes from operations staff, including signalers, maintainers, and operating managers. We can see from this that safety engineering requires a working knowledge of many different disciplines, and the hazard log manager needs to make sense of a range of different issues in order to document them and ensure that they are properly resolved. The hazard log manager works in a systems engineering environment. The hazard log or record is evidence of the safety work and risk management that has been performed when making a change to the railway. It can be provided at project stage gates and at points in between for internal consideration. Specifically, some things the hazard log supports are safety cases, independent. The introduction section will describe the purpose of the hazard log and indicate the environment and safety requirements to which the system safety characteristics relate. Within the introduction, we should find statements on a number of things, such as the aim, purpose, and structure of the hazard log. Everyone who reads this document needs to be able to follow and understand it. The process for managing the hazard log. such as who may modify it and the approval process for each new version. A system description or reference to one. Note that to be compliant with CSM requirements, there should be a full system description available. We'll be covering that in more detail in Chapter B 4.6. But the kind of information that is needed includes objective, functions and elements, boundary, interfaces, environment, existing safety measures, and assumptions. The journal should describe all amendments to the hazard log in order to provide a historical record of its compilation and provide traceability. Changes can be to individual records, hazards, their causes, accidents, etc., or to the structure of the hazard log itself. As a minimum, the date any record was last updated should be visible to anybody reading it. If the hazard log is stored in a database, then it may be possible to use the intrinsic change recording facilities to maintain a journal semi-automatically. The directory should give an up-to-date reference to every safety document produced and used by the project. This list can be kept separately to the log and may be generatable from a document control system where documents have been appropriately tagged. Remember that many safety documents will be referenced as evidence within the hazard records themselves. Documentation to be considered includes safety plan, safety requirement specification, safety standards, other safety documents, incident-accident reports, analyses, assessments and audit reports, safety cases, and any key correspondence with the relevant safety approvers. There should be a defined list of hazards, ideally a manageable number, as we have previously discussed. Each hazard should have a unique identifier, a clear description, and an indication of the associated accidents arising from it, mapping. We have discussed quite a lot about the actual hazard data during this chapter. The hazard data is the core of the information that the log is there to collect. The incident data section should be used to record all incidents that have occurred during the life of the system or equipment. It should identify the sequence of events linking each accident and the hazards that caused it. Incident data should include a unique reference, a brief description of the incident itself, a reference to a report describing an investigation of the incident, a description of any action taken to prevent reoccurrence or justification of the decision not to take any. The accident data section should be used to record every identified possible accident. It should describe the sequences of events, and there should be a link to the hazards that may precede it. Accident data should include a brief description of the potential accident, a reference to a report giving a full description and analysis of the accident sequence, a categorization of the accident severity and the highest